Or the Module 12 Part 2 note, sampling distributions for sample proportions. This is page 2. Again, another quick example dealing with our sample proportion. We've got a recent student of CCD students. 17 out of 121 believe there is life on other planets. When we divide that, we get a sample proportion of 0.1405. Again, we are going to continue being accurate to the 10,000ths place, so we are rounding to 4 decimal places. Central limit theorem for proportions is a little different than for our means. We've got a simple random sample of size n with a population proportion of p. Here are the conditions that need to be met. If we multiply n times p times 1 minus p, it's got to be greater than or equal to 10. P is the proportion. 1 minus p would be the complement of that proportion. Okay. We also want to make sure that our sample size is smaller than 5% of the entire population. That doesn't typically come up too much. Sometimes we don't know the size of the population. We are going to assume that what we're given is what we need to work with. Okay. If those two things hold, we know the shape of the sampling distribution of p hat is approximately normal, same as we dealt with sample means. The mean of the sampling distribution is the population proportion, same as with the sampling distribution for sample means. Standard deviation looks different though, and so let us highlight that here. So there is our mean of sample proportions. Here is our standard deviation of sample proportions. Square root of p times 1 minus p all over n. So proportions are kind of nice. We can figure it out with the population proportion. Don't have to have a standard deviation. We typically don't. So let's talk about how we find the z-score for our proportion. We've got our sample data, our p hat, minus our population proportion, divided by the standard deviation for those p hats. Notice that this looks the same as when we are finding z-scores for an individual or a sample mean. It's just the notation for the values that are different. Okay, finding p hat. This should have been above before we did it. Space wasn't working out. So our x is our number of occurrences. And our n is our sample size.